Right, question 11, another exponential question. And yeah, another modelling question. It's rather similar to the earlier one, actually, isn't it? You probably wouldn't get two of these on a real paper. I think I inserted this question because I had to take some integration out. So we've got concentration of carbon dioxide in the Earth's atmosphere measured from 1960. T is the number of years after 1960. So do be careful you understand what the variables are. And C is the mean yearly concentration of carbon dioxide. Okay, so we've got two data points again. So once again, we're trying to solve for the constants. We had a plus B before, didn't we? Now we've just got an A times B. So, okay, so let's go for this. So the equation C equals A B to the T. And the two data points, now we've got 1980, that is T equals 20. And 2020, that is 60 years, isn't it? So T equals 60. So the two data points are 339 equals A times B to the power 20. And 414 is A times B to the power 60. So that's equation one, that's equation two. This time to solve those, we're going to divide. So part one, we want to find B first. It doesn't really matter, to be honest, but that's the natural way to do it because we want to divide. So equation two divided by equation one gives us 414 over 339 equals B to the power 40. And then from there, we just take the 40th root. There's no logs required here because it's just B to the power 40. We want the 40th root. So the 40th root of 414 over 339. And we shove that in the calculator. One or two people tried to do this with logs. So you've got a general root button on your calculator and you want the 40th root. 414 over 339. We also had some misreads like 441 instead of 414, that sort of thing. So do be really, really careful. I know I've made quite a few mistakes. They want this to 3 decimal places. So that is 1.005 to 3 dp. Okay, so that is my answer to part one. And then part two, we've now got to calculate A, so we just sub back in to either of the two equations. So equation one tells us that A is 339 divided by B to the power 20. Now I've still got the accurate value on my calculator, so I'm going to use that. So that is 339 divided by answer to the power 20. So I'm using the answer button for the accurate value, and that is 306.760 dot dot dot. They only want the nearest integer. So A is 307 to the nearest 1. So that's the first two bits. So we have our model. This time they didn't ask us to state the equation, but good practice is that we should. So it's C is 307 times 1.005 to the T. That's our model. Now, they didn't ask us for that, but that's what it is. So part B, with reference to the model, interpret A and interpret B. This is a little bit controversial. The value of A, so A, which is 307, this is not controversial, is the initial concentration. Well, oh, hang on. It's the initial mean yearly concentration. We should probably write it out properly. It's the initial mean yearly concentration of CO2 in ppm, and by initial we mean in 1960. Okay, now II is the one that was a bit controversial. B, which is 1.005, is the multiplication factor, or the scale factor. You've got to find a word. The mark scheme just said factor by which the concentration increases each year. I would have allowed the word proportion. It's the proportion by which the concentration increases in each year. The mark scheme only gave this answer of factor. It's the factor by which the concentration increases each year. There's no harm in kind of demonstrating that you understand that 1.005 means 0.5%. So you could say, i.e., it increases by 0.5% each year. There's no harm saying something like that because it shows you understand it. But what you can't say is you cannot say not the rate of increase, because the rate of increase would be dc by dt. Okay, and we haven't differentiated anything here, so you cannot say the rate of increase. All right, don't use that word rate. It's not correct. Sorry about my writing. And then using the model, find the year when the mean yearly concentration is predicted to reach 450. So we're solving the equation. So in part C, we're solving 400, just double check, 450. So C is 450. So C is 450, implies 450 is 307 times 1.005 to the power t. Now we divide by the 307, so 450 is 1.005 to the t, and then we do need logs for this one. So t is log to the 1.005 to the power of 450 over 307, and that comes out to be log 1.005 of 450 divided by 307, 76.671 years. Have we answered the question? The question is, find the year when the mean yearly concentration is predicted to reach it. So this is during the 77th year after 1960. So therefore it will reach 450 ppm in 2037, during 2037. Okay, actually they allowed 2036 as an answer as well. I guess the idea was to take your answer here and round up, but they actually also allowed that. The only other thing I was going to say about that is that this answer here is very, very sensitive to this 1.005. If you had used, for example, a more accurate version, if you hadn't rounded this to 3dp, or you'd use more dp, it will change this answer by quite dramatically. Okay, it's very sensitive to a slightly different base. If I changed it to, I can't remember what the exact answer was, but if I change it to 1.0051, it comes out at 75. Okay, it's not that different, um, but it is quite sensitive to that answer. Certainly, if you'd rounded it to 2 decimal places or 3 significant figures, if you'd done 1.01 as the base of the log, so 1.01, you would have got 38 years, almost half out. Okay, so do be careful to use the accuracy that they've specified. So I think that's all I have to say about that question. They did allow 2 at 2036, but just be careful about accuracy there. Okay, so that was question 11.